there's a big interest, and there's a big overlap too with permaculture ideas, is using natural materials, particularly those that are most abundant locally and most suited to your particular climatic conditions. And a few of the more common ones is cob, which is a mixture of kind of subsoil materials, which are generally quite high in clay with an gravel aggregate, and to mix in straw with that or some other kind of fibrous plant material, and to create a moldable building material that you can then, like a potter, kind of create any kind of shape that you want within your house. And it's particularly well suited for creating curves and to be able to make really interesting walls which incorporate bottles and interesting windows, and it's basically just having a moldable material that you can create any form with. Some of the characteristics of cob is that it stores heat well, so it's a good passive solar material as far as when it receives direct sunlight, it will store that heat and re-radiate it slowly. But being a dense material with very little air spaces in it, it won't insulate against heat loss very well. So it's quite well suited to a Mediterranean type climate where heat insulation is not such a big factor, but the ability to moderate the temperature within the house by absorbing the heat and re-radiating is quite a useful feature to have. There's other techniques that incorporate that earth building idea. So there's rammed earth, which is a little bit less complex as cob, because you're not working on the binding materials of the different materials in cob, such as the straw and the clay, and being quite careful in the selection and the composition of materials to achieve a good binding substrate. With the rammed earth, you're compressing the high clay content subsoil, and it's the compression of the material that's providing the strength rather than the binding of the particular properties of the material. Hay bale is often incorporated with the cob building techniques, and with the hay bale it's using the structure of a rectangular type hay bale and using that as a basis for your form in the construction of a house design. And it's basically like building with Lego. You've got a building block, and you create your whole house around the proportions of that hay bale that you've got to work with. And some of the advantages of hay bale is that it insulates against heat loss very well, because it traps a lot of air within it. Doesn't store heat very well. It hasn't got any density of substrate in it that really allows it to store heat well and re-radiate it. But if you combine it with cob, so if you make use of the ability of cob to store heat and then the ability of hay bale to insulate against heat loss, they work well together. So on the southern end of a house in New Zealand, for example, where you want to store heat, so you want to have a cob wall on the interior side of the house. So this is inside the house here, and that will store sunlight that will hit that wall and then re-radiate it out again. And then by having a hay bale wall on the south side, it will then insulate against the heat loss from that cob wall from getting to the outside. And on the outside of the hay bale, you'd want to then do a thin earth and lime render on the outside of that to give it some weather protection, to stop the weather, the rain getting into the hay and causing it to rot, or to also create a good permanent seal to stop vermin getting into it and spoiling the hay too. And one of the benefits of using the hay bale is that the lime renders that you can use to achieve that will stick quite well to the hay bale face. So instead of having to scratch up and roughen the outside as you would with a cob face, the rendering will stick quite well to a hay bale face. With these building materials though, there's some special considerations that you need in the design of a house. One of them being is having a good overhang with your eaves to provide good weather protection, because the cob and the hay bale, being natural materials, will, if they're exposed to the weathering, will absorb that water, and the water will get into those materials and weaken their physical structure and cause water to leak into that house and cause damage in that house. So you want to really keep them dry, and it will rot the hay as well, which will degrade all of that and cause the house to slump in the area where the hay is being rotting. So you want to protect the top of the house well with a good overhang of an eave to avoid rain being able to get onto it. And particularly in areas such as the west coast of New Zealand, where you're getting driving northwesterly winds, you want to make sure you've got a good generous overhang in those eaves, perhaps associated with a patio or a deck area, to really protect the side of the house against those driving northwesterly winds. So that deck patio design would particularly be useful on the south and the west side of a house where the dominant winds are coming from in New Zealand, and then on the north and the east side of the house where we don't generally get so many strong winds, you can get away with a shorter eave because there's not so much requirement for weather protecting. And on those sides of the houses, it also allows you to get good sun access into the house by not having too big an overhang. The other thing is having a good foundation to the house. So often stone mortaring is used to create a good foundation to the house, and that stone will just prevent a water barrier to stop water rising up from the ground, and any surface water that's flowing along the surface of the site is not going to get into your earth cob or hay bales. That will be protected by having a good foundation of rock on the base. That foundation can be further enhanced by having a trench on the uphill side in particular, so that water that is running down the slope will enter into that trench and can be redirected around the outside of the building area, so that it doesn't get into the foundation of the building and rise up into the materials and cause damage. So when you look at the plan view of such a house, and it's on a slope with uphill being up here and downhill being down there, and you got your house site, you can do a few different things. One is incorporate swale designs in your permaculture setup, and those swales will help capture and redirect the water from flowing down into your house site. You just don't want to locate holding dams above where your property is, because if they burst or there's some fault in their construction, you don't want a big deluge of water coming down your slope into your site, which is going to be very bad news indeed. So the water that you hold, you want to make sure that the overflow is in a gully away from the house, so that it's not going to cause problems. But by capturing it in that swell, it's going to help reduce the flow of water down that slope and redirect it away from getting into the foundations of the house. And then just on the outside perimeter, you can create another trench that will capture the water that's flowing down that site, and you can direct the overflow of that trench back into the kind of gully that's the water's flowing into in that site. And then where the eaves are on that house, creating another trench on the drip line of those eaves, so that as water's coming off those eaves and falling the ground, instead of being then directed into the foundation of the house, it will be captured in a trench and redirected around the outside of the house to protect it from getting into the foundation.